Hi there, and welcome to another Papetti Math YouTube video tutorial where we're going to be finishing up our study of solving systems of equations by substitution with exercise number 5 right here, where if you recall in exercise number 4, we just looked at a scenario where there were no solutions. And the graph of a no solutions system of equation would be two parallel lines because those two lines would never intersect. So let's go ahead and see where exercise number 5 takes us, another unique solution that you might see in Algebra 1. So let's solve the following system of equations using the substitution method first. Again, I know what y is equal to. Y equals 4 minus 2x. So wherever I see a y, I'm going to substitute in a 4 minus 2x. So I'm going to have negative 4 times 4 minus 2x is equal to 8x minus 16. I'm going to distribute that negative 4 after I've substituted in my y value of 4 minus 2x. And I'm going to get negative 16 plus 8x is equal to 8x minus 16. Now I want to get all of my x's to one side, all of my constants to the other. So I'll start off by subtracting 8x from both sides. You're going to notice that you're going to be left with negative 16 is equal to, well, the 8x minus 8x cancels out. This 8x minus 8x cancels out because that equals 0 as well. You'll get negative 16 equals negative 16. So now you have a constant that's equal to itself. Is that equation true? Is negative 16 the same as negative 16? And the answer is yes, but how often is negative 16 equal to negative 16? And the answer is all the time. So this would be one of the cases where you would write that there are infinite solutions to this system of equations. When you end up with a constant equal to itself, you have infinite solutions. So now we're going to take a look at what that looks like on a graph. And we'll start off by graphing 4 minus 2x. So that's actually the same as the graph of y equals negative 2x plus 4. It's just not an mx plus b form. So don't be tricked by that because our y-intercept is actually at positive 4. And our slope is down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And we'll go in the opposite direction for as many we could fit. Okay. We're going to connect these points with a line. There we go. And we're going to put arrows on that line as well. Okay. So now that we have that first line graphed and out of the way, we're going to isolate y for this second equation. Again, I'm going to make it a little home over here that we could have our isolation going on. Well, negative 4y equals 8x minus 16. And we're going to divide both sides by negative 4 to see what happens. We're going to be left with y is equal to negative 2x. Negative 16 divided by negative 4 is positive 4. Hold on a second. That's the same thing as up here. But let's graph it and see what happens. We're going to have a y-intercept of 4. Oh, there's the intersection point. And then a slope of negative 2. So we're going to go down 2 over 1. Oh, wait, there's another intersection point. Okay. So we'll go down to right 1. Ooh, another intersection point. Oh, that's fine. Negative 2. Oh, right 1. Oh, we have another intersection point. Okay, so we'll keep going. We'll go down to right, another intersection point, and down to right. We'll go in the opposite direction. We'll go up to left, up. Oh, so we graphed the same exact line right here, if you've noticed, the same exact line. And every single point I graphed had the same point as the previous line. Yeah, it might sound a little redundant now, but what we're doing here is actually graphing every single point on top of every single point that we had before. And that's why there's infinite solutions, because if we were to go on forever in either direction, we would intersect this line infinitely many times. So the graph of a line that has infinite solution, or the graph of a system of equations that has infinite solutions, is really just the same line graphed twice. Now, if this video was helpful in seeing what infinite solutions in a system of equations looks like, give this video a thumbs up, and you're ready now for our final method in solving systems of equations, which is systems by elimination. Good luck.